and welcome to another Solar Squad update video. My name is Abisai, this is Kameron, this is Zach, and this is Mandy. Last week we left you guys on the plans on working on all of the electrical components, and we even showed a quick schematic of what our circuit would look like and also our new plans using our solar cells. Now we have great news for you. In this next video we will be showing a little bit of what we've actually done with those solar cells, kind of explain what our new plans are functioning with our design. And of course, welcome to another video, this update video number 4.
And now for voiceover done by Abisai over the new design that we came up with.
So essentially what we have here is a modified version of our first prototype. As you can see, we still have our solar cells in the upper compartment of our device, and down here we have a breadboard. Now, of course, we didn't really put a cell phone in this actual prototype because we are still in the stage of deciding whether we actually want it on the platform with the entire device, or if we just want it unattached whenever it's not being used. But now, of course, to the more important part. So here, as we showed in the video, are the rubber wheels that we have been able to obtain from the robotics back from home. And right here is the VEX 393 motor. Now, what's unique about this motor is that it has an axle compartment on the side of the motor. However, the only downside to it is that it has to be attached through the side. Now, this is of course the top view of the entire device, and so all we really have to do is just extend this part just a little bit just so it can connect. And of course, these axles are the ones that we would be using. For those who may be wondering, why are we using a straw? Well, this is the purpose of our straw, so it will be fully glued to our base. And this axle is actually a metal axle that was partially shown in the video that connects directly into its designed motor. And in the back is the long wooden axle that Zach showed us that we obtained from Hobby Lobby. Now, of course, as I said, this is just a modified version of the first prototype, but of course it seems more efficient, has more room, and looks to work the best as of now.
So today we went on a trip to Hobby Lobby and this ice cream shop, I don't know what it is, Bubblicious. And we picked up these straws. They let us have them for free at Bubblicious. And then we went to Hobby Lobby and we were gonna buy crafting wood for the mechanical shop to use it. But we just found this really thick foam. It's a lot better than cardboard, and it just looks nicer. And it's just gonna be easier to cut, and it won't be that hard to work with like crafting wood would be. So we just found that using this is a lot lighter, so it won't be too heavy for our new motor to make the car move. And we bought this wooden rod to use as the back axle for our car.
Now, as in last week, Kameron was explaining about a new motor that we were thinking about introducing to our project. Right here we have the VEX 393 motor. Now, we switched to this motor because the last motor took 12 volts, and this motor only takes about 8 volts, which would help us with our power supply and not requiring too much voltage to power it. Now, another change we've made, or not really change, but something we've added, is I was able to go home and speak with my former robotics teacher, who lended us these 4 wheels that are perfectly round, so we don't have to cut anything. Now, of course, each one of these actually has its prices on its website, VEX website, and I would say a good range for these materials is about $15 to $20, depending on the amounts of packages you buy or purchase. But thankfully, we were able to obtain these at no charge whatsoever, and it's a big plus when it comes to saving money for this project.
This past couple of days, we're in the electrical engineering building and we're testing our solar panels. With the voltage meter, we got the opportunity to test the amount of volts that the solar panels can produce with light shining on top. It turns out the solar panels can produce up to 16 volts. Right now, we're in the process of testing the solar panels in different locations to see how much voltage the solar panels can produce.
So, thanks to our testing in the electrical engineering building with our voltage meter, was it? Yes. We were able to figure out exactly how many volts we could possibly get from our solar panels. However, in different conditions, the solar panels produce different amounts of voltage. So, we need to go into our classroom and see how many volts we get from the lights in there, and if it'll be sufficient to power our motor. Additionally, it's possible that we could get too many volts charged by our solar cells. So, we talked with the electrical engineering staff in IEEE, and they told us about this really cool tool called a resistor, which basically slows down or reduces the power or voltage that goes through your circuit. So the reason why we're doing this is because if there are too many volts that are sent to our motor, the motor will overrun and explode. Or maybe not explode, but burn out. And we don't want that. So with the power of resistors and going to the classroom and testing, we can figure this out and make it perfect.
And now a quick montage of us at Hobby Lobby in the electrical engineering building.
Got out of Hobby Lobby, and we got some materials ready for our project, some foam board and yeah, got it really cheap, and I will update you guys later on the video.
And that's our video, so thanks so much for watching, and we hope to see you next week. Tune in for update number 5, yes, and Solar Squad out.